Need a minute. And let's start the screen share. All right, so the next thing we need to consider is, what does subtraction mean? So we decided addition means to combine and count. So if I said, what is 8 minus 5, you would come up with an answer for me. What would you say the answer is? Okay, so the question is why? What does subtraction mean to you that you come up with 3? Take away? Okay. My screen is freaking out, isn't it? What the hell is it doing? There's a light flickering. Are they connected? Probably not. Oh shit, I forgot to hit share. Hello, internet. Isn't that cool? Like the infinite mirror thing? Okay. Okay. Sorry, internet folks. In the future. All right, so subtraction, 8 minus 5 is 3. Why? Because we have the idea of takeaway. So then we have a story evolving here. Okay. So the story goes something like this: from a group of 8 things, maybe they're coins. 1, 2, 3, 4, 5, 6, 7, 8. I want to actually take away three things, or 5 things, sorry. So then I say, okay, I'm going to take that one, and that one, and that one, and that one, and that one. And then my story ends with this leaves 3 things in the end. Okay. So that is the takeaway version of subtraction. Now the question is, are all subtraction stories takeaway? Because if those were my 5 coins and my brother just took them, that's violence, right? Things are not going to go well. Now maybe I was going to give them away. Okay, fine. I could say giveaway instead of takeaway. That still works. But is that the way all subtraction problems work? No. So can you give me an example? She must have.
I drove around. Yeah, she was dawdling.
Okay. Was there still a sign on the basement window?
Yeah.
Okay, I'll find her. Thank you, Bob. I owe you a beer. Okay. So what other stories might I give to describe 8 minus 5 that's not takeaway or giveaway? We got a bunch of head nods. Yeah, there's a different way to do this, but what? What is it? I lost. That's still taking or giving away. I lost money to you. I got to give it to you, or you're taking it from me. Still the same idea. What do you mean? Just moving it over. Yeah, I'm going to move over my money to you, so I gave it, you took it. Same thing. So I believe there are other ways to do, there are other physical things that mean subtract. What is it? The difference. What do you mean by difference? Can you give me an example? You're on the right track. What's that? How are they different? Okay, so I have 8 coins. You have 5 coins, right? I have 3 more coins than you. I didn't take anything from you. You didn't take anything from me. Yeah, so we find the difference. Excellent. Good job. Emily, oh, high five, sorry. Good job. Okay, so finding the difference between 2 numbers isn't really a takeaway. We're just comparing them. Okay. Okay, so it's a comparison between 2 numbers. So Gary has 8 coins. 1, 2, 3, 4, 5, 6, 7, 8. Emily has 5 coins. 1, 2, 3, 4, 5. They are alike here and here and here and here and here. this shows that Gary has 3 more. Would it make sense to say Emily has 3 less? Could I state it that way too? Yeah, it's the same subtraction problem. It still demonstrates that 8 minus 5 equals 3. We just have to decide whose perspective shall we phrase it from. And that's just a comparison. We're not taking anything away. That's a totally different physical model. Do they both involve sets? Yeah, totally. So with addition, there is a set model, the set model. With subtraction, it turns out there are 2 different set models. There's the takeaway set model, and then there's the difference or comparison set model. Yes?
Shouldn't it be, like you said, depending on whose perspective, shouldn't it be using the large number first? Otherwise, the kid will think. So it doesn't matter which side is which, like adding.
That's a good question. So with subtraction of whole numbers, we're always going to do the smaller number from the larger number. Okay. And that gets into an idea in arithmetic called closure. And closure has to do with what kind of answer do you get. So what we're doing here, like with addition, we took a whole number plus a whole number. And what kind of answer do you get when you take a whole number plus a whole number? You get another whole number. So what we say is addition of the whole numbers is closed. However, is it true about subtraction? If I take a whole number, oops, wrong letter, and I subtract a whole number from it, am I always going to get a whole number? Five minus 8 equals -3, not a whole number. Okay. So not necessarily a whole number. So subtraction is not closed for the whole numbers because sometimes we don't get a whole number answer. So closure in math means that when you operate on 2 things, you get the same kind of thing. We don't have closure here. We get things that we didn't know about, that weren't in our initial reality. Whole numbers are our initial reality. Now we have a whole new reality and we have to figure out how do we explain negative numbers? Do they exist? I've had students in calculus that said negative numbers don't exist. They're just figments of our imagination. And I said, tell that to my bank, right? Because I think I own this house, but I don't. They own it. Okay. So I'm in the hole at the moment. I just kind of think I own it. So we're not closed here. And there's some weird homework questions about closure. You're definitely going to have to ask me about them if you get stuck on Monday. All right. Can you think of other ways we could model subtraction? So we've got the takeaway model. That makes sense. We got the comparison model. Yeah, there's situations where that arises too. Other models do you think we might pull out for subtraction? I have 2 others in mind. One is the result of what we did for addition. What was our other model for addition? Well, the combine kind of relates to either the comparison or the takeaway. So we've got that covered. What was our other addition model? Regrouping is a matter of having to deal with place value. So that's not a model, it's just a consequence of our number system. Keep going. The number line. Yeah, the number line is a different physical model. So we could hop around on a number line. I'm going to let you read about that in the book. I think that's pretty self-explanatory. There's another algorithm, though. Once we start playing with the blocks, we're still going to pick one of these models to use. So we could use the blocks to demonstrate takeaway. We could use the blocks to demonstrate comparison. We couldn't really use the blocks to do the number line model. But check this out. Let's stick with the 8 minus 5 equals what? What could I add to 5 to get 8? Let's see, 5, 6, 7, 8. Ooh, 3, yeah, counting up, or what do I add? Yeah, so I call it the what do I add model. The what do I add model. We could definitely call it the counting up model. And somebody could argue that this is really just another version of the comparison model, because we are doing a comparison when we count up to the other number. But I think it's got a pretty different physical representation than the comparison does. So I, in the book, consider it a different model. Some other teachers would argue it's just a special version of the comparison model. Yes?
Have you heard of the part whole mat model?
Repeat, part
Whole mat.
whole mat.
May I show you the board?
Yeah, come on up. Part whole mat. This is new to me. Awesome.
Okay.
You get to use the
So-
magic pen.
Okay, awesome. So you do is you draw a box. You draw a smaller box on top of that. Then you divide your box in half. So you have, like, say you have two numbers. Like, say you have your subtraction problem is like 9 minus 5. So you take your bigger number. You always start with the bigger number up here, and then you'd have 5 of something. Let's say 5 circles. And then you tell the kids, how much do you have to count up from this in order to get that?
Oh, cute.
So they count 1, 2, 3, 4, 5, and they count up here 6, 7, 8, 9.
Okay, so
So
there
they
you
go
go.
6, 7, 8, 9.
Right, so it's a
There you go.
physical version of that what do I add or count up. That's beautiful. I love it. Thank you very much, Jared. Cute. All right, so, and what you'll find is there are other ways to model things out there. We've got two different set models. We got the takeaway, we got the comparison. We could use base 10 blocks with either one. Just the picture will look slightly different. So let's start switching over from models to algorithms by using the base 10 blocks. So let's see, I'm gonna make up a couple of numbers. How about, let's see, what's my goal here? Yeah, do an easy one. Let's take 35 minus 12. So what I like you to do is get out your base 10 blocks and show me 35.
Oh yeah, I forgot why they call it a part whole mat.
Okay.
It's because you'd actually have physical mats you would use.
Oh,
One thing. And
okay.
Also, it's like
so they have physical mats.
yeah. And
Yeah.
as an addition, you actually use a hand signal, right? Where you have
Okay.
the number you start. Like say you have 3 plus 5.
Yeah.
You have 3 plus 5 equals 8.
Okay.
So,
Part whole. Oh, cute. Part whole. I like it.
There was one version I saw on how to subtract. It was the you said the what did I add or where to go version, and what they basically said was like if it was 8 minus 5 equals what, they said put the equals place in place the negative and put a plus between the 5 and the blank. So it's like 5 plus what would equal 8.
Yeah.
And then
Yeah, so yeah, I'll do some more examples of that. What do I add in just a minute? So here's my 35, right? And I'm gonna go steal that for my board here. Let's see, where's my steal thing right there, right? Okay, so here's my 35. So right now, because I've only drawn 35, I'm set up to use the takeaway model. So I could just make a note here. Take away 12, and so I can say, okay, boom, boom, I took away 12, and then I can say, I could just count, right? That leaves 23. which is the way we do it here. 5, I lost 2, I have 3 left. 30, I lose 10, that leaves me 20 left. So that's the takeaway version. The picture happens really in kind of one shot. I draw my main number, and then I just mark off what I'm taking away, and I'm done. I just count whatever's left. How would the comparison model look different? Yeah, I'd have to draw 35 and I'd have to draw 12 and then line them up to compare them. So let's draw that on another picture. So let's bring this over to a new screen. I'd have to show my 35, and then I'd have to whip out my blocks and show my 12. Let's get a snapshot of that. And so then I can start comparing them. And so I'd have to link them. Okay, so these two go together, these two to go together, and these two go together. Okay, so that leaves 23 more. Or there's 23 left, however you want to write it. Okay, but that one requires 2 pictures. You have to show both the 35 and you have to show the 12 to do the comparison. But they're both necessary because not every time we do subtraction in life are we doing a takeaway. Sometimes we're saying, hey, you get this much, I got that much. How are we apart? Okay. I want to buy this toy. It costs this much. I have this much money. Compare, see where I'm at. What's the difference? Okay. Questions on that? No? Okay, so this is activity 2 in the workbook. Okay. So I just want to show you a couple other crazy things about subtraction. So different ways to do subtraction. Oh, actually, no, let's do one more with the blocks. Let's suppose we had 32 minus 17. We want to show that one. Let's do takeaway first. Okay, so first, show 32 with your toys. So here's my 32. I have a slight problem. What's my problem? I can't take away 17 right now because I only have 2 ones. So what do I have to do? I have to trade in a 10 for 10 ones, okay? So I'm just gonna make a little note. Oops. Trade 1 10 for 10 ones. So let's redraw my picture, or you go to your bank and do a little trade-in. Okay, now I'm primed to do my takeaway. So then I whip out my pen. Now, take away 17. Okay, so there's the 10, and then 1, 2, 3, 4, 5, 6, 7. That leaves 15. I do okay? Okay. Now, does that have anything to do with the way we learn to subtract, which we call, what do we call our subtraction method?
Borrowing.
We call it borrowing. Physically, we're trading in. Okay, we're not really borrowing, we're just trading something in. It kind of looks like borrowing when we do it. So let's see. 2 minus 7. Problem, can't do that. So I have to trade in one of my 10s, which leaves 2 of them. Oh, shit. And that is my daughter. Hang on, give me 1 second. Hello. Oh, you must not come all the way. Okay, so he missed me, so I'll be there in a little while. Okay. So, so again, can we see this right here is why we're allowed to borrow. Okay, that's why we're allowed to borrow. So now I can say, oh yeah, I can see my 12 right there. Isn't that 12 ones? Okay. And so 12 ones take away 7 ones leaves me 5 ones. I can pretty much do that. And then I had 2 10s. I'm taking one of them out, so that leaves 1 10 behind. So there's my 15. So the toys can justify why we do that crazy shit on the top. And the kids are going to think that's insane. They're going to think that's totally nuts. I'm going to show you another way to do it based on the number line. So let's see. So let's see, I'm trying to do what? 32 minus 17. Oh, that's a lousy looking 3. Okay. So 17 lives somewhere over here, right? And 32 lives somewhere down the road, say over here. And usually we stack 32 minus 17, 2 minus 7. I can't do that. What I would really like it if that weren't a 2, but if that was a 12, that would make my life so much easier. Now suppose I just make it a 12. What number have I represented here at the top? No. What's this represent? 30. What's that represent? What's 30 and 12? Ah, I've just written 32, 42 right there. 42 lives somewhere over here. Okay. What did I do to this number? I bumped it up. How far? I bumped it up 10 spaces. Why 10? Because we have a base 10 number system. That's why. I like 10s. Okay. Well, hey, if I'm going to bump that guy up 10, I'd better bump this guy up 10 also. And so I'm going to put that over here. There's 27. So I moved both numbers up 10 units. So there's my 27. Let's see, 12 minus 7 is 5. 30 minus 20 is 1. Hey, that worked. This is called the equal additions algorithm. So I'll do it again. There's different versions of the equal additions. The book does a slightly different version than I do. So what we do is, again, starting over, 32 plus 17. We say, this would be so much easier if that were the 12. That means I just added 10 to that number. So then I add 10 to the bottom number, but I do it in a different place. The 10 here makes the addition convenient. Might as well put the 10s column there. Why not? Okay. And so what I've done is I'm considering the comparison model here, because the comparison model says how far are the numbers apart. And if I shift them both the same distance along the number line, aren't they still the same distance apart? That's why that works. And the nice thing about that is if you have a number, oops, wrong way, like 2001 minus 1969, borrowing on that problem is a bitch, isn't it? Because you got to do 10s and 9s and it gets all confused. But if I do the equal additions algorithm, it's just a one step at a time process. Make that a 10, up that by 10. 11 minus 9, that's easy, right? 2. 0 minus 7, can't do that. But if I made that a 10, I bump that up also. Ooh, is that legal? Let's see. Which column is this? The 10s column, right? I just put in 10 10s, which is how much? 100. This was what, 900? Now what is it? 1000 or 1000. Didn't I just bump both things up by 100? Yeah, here I bumped them up by 10, here I bumped them up by 100. You can just keep doing that all day long. Okay, so 10 minus 7 is 3. 0 minus 10, can't do that. Make that a 10, bump that up to 2. 10 minus 10 is 0. 2 minus 2 is 0. Oh, the answer must be 32. Yeah, we could certainly count up, and that leads to a different algorithm. So it turns out subtraction is more complicated than addition, and there's a lot of different ways people do it in the world. I think I know 10 different ways to subtract. And they're algorithms, processes that get me the right answer, that are totally different than the process we grew up doing. They do this some places in the world instead of what we do. Okay. All right, so I'm going to shut up here. I think that's enough for today. Let's take a look at the activities for a second. The recording doesn't need to have that in it. How do I stop the recording? Somewhere over here.